So guys, welcome on my YouTube channel. So today topic which is we are going to discuss that is Ether channel, and inside the Ether channel, while using the Ether channel, what kind of other protocols which is we can use that, which would be regarding VSS like switch system, and how we can enable the virtual switch system. But before configuration of the virtual system switch system, we have to check basically ether channel. Okay, so without any ether channel we cannot configure virtual switch system. Okay, so it depends upon the switch models, what kind of switch we have, what kind of ports we have, like we will discuss. Okay, so let's start. So let's just start with the Ether channel. Okay. So what is the Ether channel? The Ether channel is also called Link Aggregation Control Protocol. Okay. Link Aggregation Protocol. So basically, why we need Ether channel? First of all, this question, let me ask, who is going to give the answer for that, guys? Who has any information, or if anybody have any idea about the Ether
Actually,
channel? Yes.
yes, I can answer you in short. Is that to bundle the links? Why we bundle? To get the high throughput and also for the redundancy of the link. Like we have just one link, it would if that goes down, we would not be having any redundancy or uh, we can lost the connectivity. So Ether channel provides us both things: the high throughput and the redundancy of the link.
Okay, fine.
And the third and most one is the most accurate answer would be like it also avoid the loops and all. Using that, we can achieve.
Yeah, it also work on the loop avoidance technique. That is we called spanning tree protocol. Okay, anybody else that would you want to give your ideas and all?
SSL is grouping for the several physical Ethernet link for the creating we can logically link logical Ethernet link or purpose of the provided the unless like bundling.
Okay, fine. So basically, first of all, why we use Ether channel? So, like if I say that between the two devices, if I have the link which would be 100 Mbps. Okay, now we have the large data amount which is we have to share. Suppose that this switch is in the data center. Okay, so in the data center always we have the large amount of the data, and we always need the high speed transfer, high transfer speed. What we need? Always we need high transfer rate over here. So to resolve this problem, what we have ether channel. So what we can do, we can use multiple links like 300, 100 MB, 100 MB per second link, which is we have. So we can use we can bind the four links into the one logical link, that is we called port channel. What we called port channel. Okay, so this link which is we are going to create, that is port channel. But the link switches we are using between the switches, first of all, the election criteria would be same as like your spanning tree protocol. Okay, so whatever the election criteria which is we have between the switches, that would be same as for that. Okay, now once we create the port channel, so all the data would be going to transfer with using this port channel only. So like suppose that if I need 400 MB per second of the data transfer speed, so what we can do, we can use the four link over here, and we can bundle this four link like 100 MB each. Each link we can bundle into the one logical link, so that using 400 MB per second we can transfer using this speed of the data. Okay, between the devices. So that is the most important things, and it also provide the redundancy. We do also have the multiple softwares, multiple different protocols with that, which is comes with it, which would be VSS, virtual switch system. So like we do have stack cable. Did you heard the any kind of name about the stack cable and all? I think you can't. So
Yes,
this,
yes, yes.
yes.
We
Mhm. So a stack cable basically where we can get this stack cable or stack port. Suppose that this port we have in the some specific models of the Cisco switch. Okay. Suppose that this switch model which is we have you can take it lower than 3000 series of the switches. Okay, so like you will get the kind of lower than 3000 series, the series of the switches, you will get the some stack port over here. Okay, so you will have to add the multiple switches, like multiple switches would be work like a one switch. How? With using this stack port, like we have the stack cable over here, that stack cable having the speed of that is 32 MB per second. Okay, so with using this stack cable we can like in some organizations we always need these kind of things, right, for the stacking and all the things. And nowadays it's very demandable, and most of the organization is gonna be prefer the stacking and all the things. Okay, so if you would have any kind of idea about the stacking and all, so they will definitely give you the some kind of project regarding that. Okay, so what will happen, like in the data centers mostly these kind of things we need into the data centers. Like suppose that we need suppose that this have the some kind of processor, suppose that any device which is we have, and this have the very lowest processor, and we need the two processor at least to send the some important data from source to destination. Suppose that this is our, here is our destination. Okay, so we want to send the data from here to here. So what we need, we always need to use to send the data using the using very large device, you can say that, or using very expensive device, or you can say that very compatible devices. So what we can do is stack cable will merge these two devices into the one. Okay, so what will happen, like whatever the RAM that this device have, suppose that 2 GB RAM this device have, and 2 GB this. So what will happen, this 2 GB will merge into the 4 GB. So you will have right now the 4 GB of the RAM. So whatever the process is running over here, that will work on this RAM and all. Okay, so that makes very easier, and that makes very faster to send any kind of data. But above the version of 3000 we do not have this stack port. Then what we have, how we can configure, how we can merge the devices, then we have ether channel. Okay, so using this ether channel we have the another concept for that, which is we call virtual switch system, VSS. Okay, so with using this VSS we can basically generate any kind of data, and we can generate the any kind of data, we can send the data, we can receive the data with using the higher link, and with using your basically higher transfer rate speed over here. Okay, so what is VSS we will also talk about, but before coming on the VSS we have to configure, we have to know about the ether channel, how the ether channel works, what kind of basic features which is we have for the ether channel, right? So then we will just get back to on it. Okay, so let's discuss about the ether channel over here. And into the ether channel we do have the multiple things to discuss, and we will also do some configuration regarding the ether channel over here, but that would be, I think, I will make the separate video for the configuration. Okay, and I will also upload it. So let's discuss what is that. So it is used to aggregate multiple physical link into the single logical link, as we discussed, right? Like we can add the 4 5 ports, 4 5 links into the one logical link, and that link will be shared, that link will be used, that logical link called port channel, right? Now, so what would be the requirement to configure the ether channel, like what kind of things which is we have to check before configuring the ether channel? Duplex must match speed, like same suppose that if you are using two devices, and you are going to bind. Suppose that this is our fast Ethernet and this cable is our Ethernet. So they are not compatible with each other. Okay, because of this is having the different speed like 100 MB per second, this link having the 10 MB per second of the speed, so they are not compatible, right? So because of duplex is not going to match, because of this duplex is different over here, speed is also different, right? So these kind of criterias we have to check, then you can easily configure the ether channel over here. Okay, so what are the criterias? These are the criterias. What is that? Speed much must match, ether channel standard must match. Okay, whatever the standard you are using like PAGP, LACP, right? Like suppose that one side you are using PAGP and one side you are using LACP, so they are not compatible with each other. Okay, so they will not able to form the ether channel between that. So these kind of things. Now, trunk allowed VLAN list must match. Like if any, what is the default VLAN which is we have? That is VLAN one, and this VLAN one is by default auto member of the ports. Okay, so this one must match native VLAN. So native VLAN is what? Native VLAN number is one. Trunking encapsulation protocol must match, means we have to configure the trunking encapsulation protocol as well, like 802.1q. What? 802.1q. Okay. Pruning eligibility list must match. Like this is optional, right? But you can check it as well. Okay. So these kind of information which is we have to check before configuration of the ether channel. Now, after creating the ether channel, STP will work. STP will not work for the switch port which are member of the port channel. Okay, like we have the two kind of port over here. Uh, Types of port we can call it. First, access port. Second, we have trunk port. Okay, so access port means we can add or we can connect with using the AND device. And device would be like your PC or any kind of things. Trunk port would be, that means it can carry all the VLAN information. Means the access port can carry the only one VLAN information at a time, but trunk port can carry the multiple VLAN information at the same time. Okay, so this kind of things would be work over there. This access port will not work. Always your trunk port should be enabled. Okay, then your ether channel you can form easily, you can, your ether channel will be formed over here. Okay, now how many types of ether channel we have? So we have three types of ether channel: static, PAGP, and LSCP. So we will discuss it this static later. Okay, so let's discuss directly on the PAGP. So PAGP is a stand for port aggregation protocol. Okay, now it is a Cisco proprietary protocol. That means this protocol is made for the Cisco devices, right? So what this happened, like what it have, this have the one drawback, that is it is only made for the Cisco devices. So that's why I will not prefer this PAGP to configure that. If you have in your organization, if you have the all the Cisco devices, then you can go for it. Otherwise I will prefer LACP, link aggregation control protocol. Okay, now you can aggregate up to 8 links, means at a single time you can aggregate 8 links in that, right? Means suppose that this is your two switches we have, so at a time you can add the 8 links in that, 3 4 and 8. Okay, so you can bind with using the range command, and you can utilize the 8 links at the same time. Okay, so like you can utilize the whole 8 links at the same time between the switches. Okay, so what are the mode switches we have? Auto and desirable. Okay, so let's discuss how we can configure over here between the two switches. So first of all, let me take the two switches from here. Now, in which condition we can form the trunk? Suppose that the two switches which is we have, they are connected with each other. Switch 1 we have, and we have another side, that is switch 2. Suppose that I have configured over here, that is auto. Okay, and I have configured over here, that is desirable. So the ether channel will be formed. Yes, ether channel will be work. If you configure one side auto and one another side autos, then ether channel will be not work. Okay, if you have configured one side desirable and another side would be also desirable, then ether channel will be formed. Okay, so these are the some conditions which is we have to form the ether channel. Because of the modes, because of whenever you are going to configure the ether channel, like whenever you are going to aggregate the ports, we must have to give the mode, right? Like which mode you want to use. Okay, like whenever you drive the car, so there will be like nowadays there will be multiple modes, right? Like city mode and sports mode and all the things. So this would be same like wood, same like as a car. Okay, so like what you need, like you need some sport mode, or sorry, you need some city mode, or you need some kind of desirable mode, or you can say that sports mode according to the car. So then you can form the trunk. Okay, this is what this is going to identify this modes. Basically this modes, how you can identify that it's a PAGP or LACP with using these modes. Okay, with using this modes you can identify that I'm using PAGP protocol over here. Okay, so auto means auto and desirable, just keep remember these things. Okay, so this kind of aggregation which is would be happen over here. Okay, now we do have the some kind of directional mode as well in that, that is silent and non-silent switch. So what is that? So what is the silent switch? It will create port channel without checking bi-directional connectivity for every port. Bi-directional connectivity, that means without checking this auto and desirable, it will form the trunk port. Okay, if you use the silent and if you would use the this kind of things. Now what is the use of the non-silent switch? It will check bi-directional connectivity for every port, both side needed desirable. It uses for the fiber optic cable. Basically this is this non-silent switch we use for the fiber optic cable, that is we have. Okay, and from the both the side we need the desirable, like the condition to use the non-silent switch, which is the desirable. Both the side we have to use the desirable, and we can use the these things in the silent switch. Okay, so these kind of things which is we have with the silent and non-silent switch. Okay, now PAGP port ID, if I'm talk about, so that would be just same as like your priority and all the things. Okay, you can give the priority, and you can then after giving the priority you can get the kind of port, whatever the port we have, flags and status, timers and intervals, all the kind of counter, timer and period. The priority you will also get it over here. So in the statically you can configure the priority over here. Okay, now then we have LACP over here. Okay, so LACP, yeah, yeah.
one confusion. Priority we can use when we can use the stacking. So we can use the priority. No?
Yeah, when we do stacking, then you can use the priority. Okay.
Okay, and others we have not any stacking. Normal configuration does not use the priority.
No,
Or auto will
then
use
there
by
is no
default.
need. There is no need. Without priority, see, if you are normal going to configure the PAGP protocol, so there is no need for the priority. Okay, like if you want to give it, that is the value of the priority which is between the 0 to 255. So always the lower priority will be prefer first. Okay, so this kind of things, sorry, the higher priority will be prefer first. PAGP control plane traffic will send from the port which has higher PAGP port ID. Okay, port ID you can say that, or priority. So these kind of things which would we have, and we never check this kind of things. Like by default this is 128, so we never go for that. Like we never check it. Okay, now, LACP. What is LACP? This is stands for Link Aggregation Control Protocol. It is what? This is Open Standard Protocol. Now, one more thing is extended over here. That is 16 link will be formed into this. aggregation protocol at a time. Okay, so it can arrange up to 16 links in a single channel group. Okay, so like you can select the 16 link which is we have. Let me just 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, so you can aggregate this whole links from here, and then you can start using whatever the switches you have. Okay, suppose that this is our switch 1 and this is our switch 2. Now, what will happen? The 8 link would be active. 8 link would be always active. 4, 5, 6, 7, 8. And 8 links would be in the standby. Okay, what are these links would be in the standby. Okay, like if any active link goes down, so the standby link will take place of that, and whatever the cost which is we have on the link, that is also going to be added. Okay, it does also matter. So always most of the organizations will prefer LSEP because of we have the multiple extended option over here. Like we have 16 link, we can bind the 16 links at the same time, and we can configure whatever we want. Okay, now what are the modes which is we have? Active and passive. Now let's discuss how basically these things is gonna be happen regarding the active and passive. So suppose that this is our switch 1 and this is our switch 2. Now if you are using one side as a active and another side as a passive, then the aggregation protocol with the channel port channel will be formed. Okay, if you are using one side as active and another side as active, then link will be not formed. Okay, if you are using both the side as a passive, then it will form. So same condition is for that as well. So keep remember that we have active passive in LSCP, and what are those? What are the others? Auto and desirable, right? In PAGP. So how you can find it out the which aggregation protocol we are using with using these modes. Okay, any doubt, guys?
Yeah, yeah.
Do you have any doubt? Any things that you have to ask?
Not yet, but Jaishankar, is active in case in Nexus in case we are using active.
And that has formed the port channel.
I think that will not work.
No, I think PPC is working now, and the port channel is working on the distribution, not the core.
Yes,
There
not the
is some
core
confusion.
switch,
So,
not on the core
we are
switch.
using the active in the core switch or the distribution.
See, on the core switch you have to use layer 3 ether channel, and on the
Okay.
distribution switch you have to use the L2 ether channel. Okay, did you got my point? So what is the layer 3 ether channel we will also discuss. Okay. Now we have the LACP system ID, okay, and always the lower system ID would be preferred. Okay, so what is that? The main switch will elect using with using the LACP system ID, and always lower system ID will be preferred. That main switch will elect active port by using port ID, and it will negotiate with the neighbor. Okay, so how we can change the system priority over here? That is the command. Okay, system priority, and the default system priority which would be we have 32768. Okay, and system base MAC address, which is we have the base MAC address of the device. Now then we have load balancing algorithm as well, because of we are like basically we know that we are using the ether channel, but sometimes we need some load balancing algorithm as well. So that is considered inside the layer 3 ether channel. Okay, so ether channel load balancing algorithm with what, that is source mac, destination mac, source and destination mac, source ip address, destination ip address, source and destination ip address, source port, whatever it is. Okay, so these kind of things, which would be, we can form whenever you want to perform the load balancing into the ether channel. Okay, so we have to use the some commands for that. Okay, so like both the side you have to use the same thing. Like if you are using one side, that is source mac, right? Suppose that this is this kind of things which is we have, and suppose that this side you are using source mac, and you are using the this side as a destination max, so they are not compatible. Means you have to use the both the side as a same thing, then the then you can is able to form, you can able to perform the load balancing protocol. Okay, now we do have the some kind of static channel, static ether channel configuration, right? Means how we can manually configure the ether channel. So this is how we can channel, how we can configure that. Okay, channel group 10 mode and on, we have to simple say that that mode which is we are using, that is on. Okay, and what is that, the channel group number, this is our port channel number. Okay, this is our port channel number. Okay, what is that? This is our port channel number. And which mode we are using? We are using on over here. Okay, so this kind of things which would be we have for that. And how we can configure PAGP? Simple. Go select the particular interfaces between the switches. Like if you have the four interfaces over here, so you have to select the range with using interface range command. Interface range command. Okay, then after that you have to use the command, that is channel group. You have to make the any kind of name over any number, you can take it one or whatever the number. Then you have to use the mode. Okay, so what is the mode? Desirable. Okay, and we can set the particular silent and non-silent switch over here. If you are using the fiber channel over here na, if you are using the fiber channel, then you can go for the non-silent. If you are not using the any kind of fiber channel, so you don't need to give this non-silent or any kind of things. Simple, you can just give the desirable mode and that's all. Okay, then you can go for a channel group number 20 and then mode auto. Okay, so this kind of configuration you can use over here. Okay, the one side you have to use auto and another side you have to use desirable. So this is you can form ether channel of PAGP. Okay, now for the LACP, which one you can? Active and passive. Okay, so you can use the active and passive over here and you can set the priority between that. Okay, so LACP port priority you can give it that as well, and system priority you can also give it. Okay, now if you want to perform the load balancing, because of I'm using the LACP, if you want to perform the load balancing, so simple, you have to use port channel load balance, and then you can do the question mark, then you will what you will find it out in the next, that is source mac, destination mac, source destination mac, source IP, destination IP, source destination IP, source port, destination port, and source destination port. This one, let me show you this one. Okay, so you will find it out when you do question mark after that. Okay, so both the side you have to use these kind of things. Okay, like whatever the things that is we have for the load balancing protocol, you can use it. Okay, so this is how we can, this is the thing which is we can perform the load balancing and we can form the trunk. Now let's discuss the layer 3 ether channel over here. So what is the layer 3 ether channel? If there is 8 link in ether channel, then 8 neighborship will established. Okay, means suppose that 8 neighborship is established and we have 8 ethernet link over here. Now 8 neighbors in entry in neighbor table, because of all the neighbors having there's some kind of entry from the some tables. Okay, so suppose that every neighbor having the entry in their neighbor table, because of every where this neighbor entry is gonna be stored into the neighbor table. Okay, so if any port goes down, neighborship will down. Okay, because of suppose that over here we have 8 ports between between the switches, suppose that. Okay, and if any neighborship goes down, so what will happen? The neighbor table which is happening over the managing, which is the managing of the neighbor table over here, the neighbors, from the neighbor table you will find it out like what is the neighbor, that is fast ethernet, suppose that 0 0/0, which is connected directly connected on fast ethernet 0/0. So you will find it out this kind of things into the neighbor table, and you will get in the front of this, that is down. Okay, so you will get this kind of option into the neighbor table, so you can realize my neighborship is goes down on this interface. So what will happen, the another interface will take place of this. Okay, so whatever the cost we have, this will add it over here, and it will just start working on it. Okay, now what we have after that, if we have 8 link, then we have to give IP in 8 subnets. Okay, means every link needs the single subnet IP address. So that means there is lots of CPU utilization, because of we need the multiple IP addresses for the 8 links and all the things. Okay, then why we go for that, why we prefer the layer 3 ether channel? Okay, what is the use of then, what is the use of it then? Okay, but in the some organizations using this because of they need it. Okay, and if you have the all the kind of different IP addresses if you purchase, so then you can go for it. Okay, otherwise I will not prefer to configure this, but we will definitely add, like we will get the lots of features if you are using the layer 3 ether channel, right? Regarding the IP addresses, regarding the your backup port as well, like you will also have the backup port. Okay, and like manually you can assign the some priority, and you can assign the particular speed for the interfaces and all. Okay, so we have multiple things that we have, and we can use it. Now, to solve this problem, we will use the layer 3 ether channel. Now, what is the configuration of that? Which is that channel group 20 mode, auto and desirable, whatever the things, and these kind of things we can do it, and we can configure the IP address on the port channel. Statically we can configure, like we have to whatever the port channel which is I have configured, and which is the mode which is I have configured on this, we can directly go for the IP addresses, and then we can do no shutdown and all. Okay, most of the time we use this. And I just wanted to show you one more thing, um, over here, that is my CCI lab. Okay, so that you can get familiar with this as well. So like what kind of topologies we have, and what kind of topics which is you will get it inside it. Let me just turn it on, and let me show you exactly how it shows, how it looks like. We have, guys, basically 4 5 topologies in that, and each topologies have the different kind of configuration. Not the kind of this only. You have the different configurations as well. If you want, so I can give you this machine as well, but it needs higher RAM and all. 163, 128. Let me turn it on and let me show you.
It is the same HP laptop.
Sorry.
So this is the same machine you told. This is the HP laptop you discussed that day, right?
Yeah.
It is the same machine.
163, 128. Just hold on a second. 163. Here is that. So let me show you the one of the topology, which would be here. This is the T-shoot topology, troubleshooting topology. Come on. Yeah. So you can see over here the DHCP, Ether channel, data centers, lots of service providers is also working over here. Basically, in this basically my MPLS and BGP is working, and every edge device is having the BGP. Okay, that is eBGP. So this one is also having the eBGP. This one is also having, because of they are from the different areas. Okay, so they will also have, they will also have the DMVPN. Okay, this is our hub and here is our spokes and all, right? You can see over here the spokes, DMVPN spokes. Okay, and over here we have the home office. So this user is getting the IP addresses from the DHCP. This one is also getting the IP addresses from the DHCP. Here is also a user which is getting the IP address from DHCP. So this is our servers and all. Okay, well, lots of topologies, very big topology I have. Like every routers, every switches needed lots of RAM and all. If it is so like 500 MB, my God, I think it's stuck. No, let me just open the some console and let me show you. Open link in new tab. Suppose that I'm going to take the access of user 4 or router number 40. Let me just show you 400 and 410. Yeah, this one. Negotiation close. Let me turn on the device. I just wanted to show you the some configuration on the switches, like how the configuration is running on that. So then you can get identified basically how exactly it works. Okay. So that's all the my main motive and all. Because of I have done all the configuration, even not only on this, I have completed the every device's configuration regarding the IP address and all the things. And I have done the lots of things over here. It takes time, guys, because of this is not a small lab and all the things. You have to wait if you turned it on. So let's let it turn on. Okay, I think it needs time. It's starting on device. Okay, now it's start. Let me take the access. Let it be. Okay. We will discuss later whenever it will turn on. So we will discuss it. Okay. So, but keep remember these things. Like always, we need to discuss this kind of things, and always we have to do that. Okay. And we will also perform this. I can do one thing. I can show you the exact solution of that. Hold on a second. H3J. And So, regarding these layer 2 technologies, right? So, let me show you the exact topology. See, that was our lab, right? That was our scenario. Is it? So let me show you the layer 2 configuration. So like port channel configuration. See, so like I have selected the range interface, range Ethernet 2 slash 0 to 1. Okay, then I have done the set it down, then switch port trunk encapsulation dot 1q switch port mode trunk. Like I have made this port as a trunk, and then switch port no negotiate. Then what I have done, channel group 1 mode active. So what is that? Active, guys. Active and passive, which mode I'm using, like which ether channel, PAGP or LACP?
PGP.
PAGP.
LACP.
So
Actually, no, LACP has the active mode.
keep remember what is that. See, PAGP have auto and desirable, LACP have active and passive. Okay, so keep remember. So what we have done after making this port into the channel group, like after making this port into the ether channel, what I am doing it, I'm going to form the layer 3 ether channel over here because of the dot 1 q. I'm going to make it this port as a trunk interface port channel 1, which because of the channel group which is I have created, which is 1. So I'm going to take the port channel over here, and then I have make it as a trunk. So then basically your port channel will work properly. Okay, so you can just see all the configuration which is would be like this, and this is the real scenario configuration, guys. Like whenever you will go for the CCI lab examination, you will find it out these things only. Nothing will change and this kind of things. Okay, so same thing you will get, and the basically output which is you must have to get, which is this. Like you have to run the command that is show ether channel summary, and all the ports would be in the p. That means port channel bundled into the port channel, right? Sometimes you will get the some kind of suspended or something like as for layer 2, or something like not in use or something like that. Okay, like you will sometimes you will get what to say, n or m, something like that. Okay, so these kind of things you will get it over there, and sometimes you will get the f over here. So that means you can get identify that okay, my ether channel doesn't form, so you must have to use it. And one more thing, just wanted to tell you, before configuration of the ether channel, like before making this command, before running this command, sorry, before running this command, switch port channel group 1 mode active, you must have to shut down your interface. Otherwise what will happen, uh, whatever the configuration that you have done on this port, so regarding IP address, regarding anything, so all the things will be flushed out automatically, it will just delete. Okay, so like some of my friend goes in the examination and he just did the same thing, and all the configuration got removed because of on this port, the not the only one configuration is going on, the lots of configuration is working on this only one port. Like if I not yeah, now it's working. Let me show you the routing table of that, then you can understand. Okay, come on. Sometimes I have tried fast. So do show IP route. Okay. Come on, what is that? Okay, the this is the switch. So let me show you. Do show ether channel summary. Come on, Cortana, what is that? So you're getting this right. So that means all the configuration which is I have done it on this. So you're getting like would be like this. And if I take the access of the routers, suppose that let me take the access of this router, because of this is the route reflector. Okay, in the BGP. So let me show you as well while taking the access of router number 13. See, IP address is never going to end. Are you getting that? These are the IP addresses. Getting
Yeah.
this? So this would be like very if you go for the step by step configuration, so you will never face any kind of problem. But if you want to if you want to jump directly from the here to here or something anywhere else, so you will stuck. Definitely you will stuck because of we do not have only one IP addresses on the interface. We do have multiple IP addresses. And if I show you the IP addresses on the interfaces, do show IP interface brief. So you will get it not only one IP address. Like see, you will get there's some loop back. And if I show you the some kind of show IP. protocols. So there will be multiple protocols is already running. Let me show you from the starting end. See, OSPF, okay, 655001. Now, after this, 655001 BGP. BGP is also running on that. So the both two protocols is running on that. And how many routes is addresses, how many addresses and neighbors, which is we have over here. See, this would be like this, 15 or 17 would be like that. So all the kind of areas and all the kind of things which is we have do show.
Using distribution, redistribution.
Sorry.
You're using redistribution.
Yeah, lots of redistribution and lots of things is gonna be work over here. If I'm talk about redistribution on this device, let me take the access of the router number 12.
OSPF and BGP.
Yeah, lots of things, not only those. We have BGP, EIG, even the EIGRP is also running over here. To show IP protocol, let me show you the protocols. What is happening? Okay. So see over here OSPF. Okay. Then we have BGP. Okay. So we have 15 to 16 routers in that. And if I show you IP interface brief, sorry, IP route. So we have multiple routes. See, this is just the starting. Now how it said. So these kind of things, guys, that is we have, and we will discuss everything later whenever the OSPF part and the other part will be there. So what I will do, we will try to troubleshoot the network. Like basically, this topology is the network, is a troubleshooting topology. Okay, so like we have to troubleshoot that particular questions we will also have for this. So we will try to troubleshoot step by step. We will do one thing, we can give the 1 day for this session for the particular troubleshooting purpose. Okay, or like after the training you can also contact me. Okay, so I just wanted to give you the some real scenarios knowledge, which is very important for you guys, because of you have the
Can you
lots
show
of.
some Ethernet channel also? Layer 3 Ethernet channel.
Okay, on which switch you want? It's the router.
Anywhere, we just want to see the configure.
Okay.
So you will just configure the IP address under the interface,
I think
virtual interface. That is a virtual interface.
that's turned off. Show run by section. I think that's turned off. That's why we are not getting that. Yeah, that's turned off. You are getting the red. Let me just do one thing. Ether channel, ether. Show ether channel summary. Okay, let me just take it. Let me show you over here. Show ether channel summary. And yeah, so this is bundled and on which port? Port 1. So on the port 1, if I'm talking about, so how the configuration is gonna be happen. So show run interface port channel 1. So this is the configuration which is we have done on the port channel 1. Okay, interface port channel 1, switch port trunk encapsulation dot port q, switch port mode trunk. That's all. And if I talk about how many ports we have bundled in that, that is the Ethernet 2/0. So if I show you, show run interface Ethernet 2/0. So then you will see over here, these are the configuration which is we have done regarding the channel group. Okay, now it's closed. So yeah, this kind of things, guys, which it would be we have for this. Okay, so I think that's enough for the theoretical part. So let's discuss the practical part of this and how to configure the port channel, what kind of things which is we have. So all the kind of things we are going to discuss in the configuration part. Okay, So I don't think so you have any kind of doubts regarding the ether channel and all. If you have, okay, I think we did not cover the VSS part. Am I right? Okay, okay, okay. Let me
Yes,
just
yes.
let me just quickly give you the some introduction. That's all. VSS. So yeah. So basically, VSS, which is we call virtual switch system, whatever we have. Okay. So now, the VSS, if I'm talk about the configuration, so the configuration would be like this, like your switch one is having the VSS and switch two is also having the VSS. Then how we can configure? We have to configure the VSS by using the some port channel. Okay, like first of all, what we have to do, we have to configure the port channel between the switches, and then we can configure. And what are the other things which is we have to follow, like superior engine, domain name, right? And module we also have to give in that. Okay, so we must have to give the lots of things over here. Suppose that this switch one configuration, if I'm talk about, so switch one virtual domain. So domain, suppose the domain name I'm giving it one. Okay, so virtual domain you have to create. Then inside this, you have to give the name for that. Okay, same as for the switch two, we have given the name, and then after that we have to set the priority. Okay, so by default, what is the priority? So for the priority, default priority is 100. Okay, but we are going to make it as a 110, because of always the higher priority will be prefer first. Okay, for the sending information. So on the switch one, we are going to make it as a 100, 110 priority over here, and the switch two for the priority would be 100. Okay, now after giving this, we are going to go inside. We have to make a port channel. Okay, and then we have to create the switch virtual link in that. Okay, did you got my point? Like, we have to bind the sport, the virtual link with the sport channel. Okay, so whatever the virtual link that I have created over here, let me show you. uh, 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 on the top, I think that was, no, 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 not here, not here. See, virtual switch virtual domain one. Okay, so I have created the switch virtual domain one, the name which is I have given switch one, and then priority. So what I'm going doing it over here, then after that I'm just calling the virtual link one inside the port channel. Okay, are you getting this? Like, we are now inside the port channel, global in. We are now inside the interface mode, and we are calling this virtual link inside the port channel. Okay, then what we are going to do after that, we are going to select the range, and then we are going to make it as a port channel on. So that's all these things we have to do now. Regarding the port channel, you can see over here that is fine, means it's working properly. So these kind of things we have to do for the VSS, and we have multiple things for the VSS, guys. And lots of things that is we have in the VSS, like domain name. We do have lots of configuration as well, which is we have to do on the VSS. Okay, so lots of things we have to discuss, like whenever you will get to some access, so you will get that familiar with this kind of things. Let me just. So, what is the VSS? Virtual switch system is a Cisco proprietary techniques to create a single logical switch out of two physical switches. Some of switches that supports these are into 6500 series and the 4500 series switches. So, like, the previous version of the 3000 series of the switches, we do have the stack port, but the upper version of the 3000 of the series switch, we do not have the any kind of a stack port or stack cable. We cannot use it. So what we have then, we have the ether channel. So by using the ether channel, we can use, how we can, like, if you do not have any things or any port on the switches, so then how you can merge these devices into the one device, how you can merge it. So we have VSS, and how this VSS work with using the ether channel, and this ether channel will work on the port channel. Okay, so this is, you got my point, how it works. Lots of things, guys, lots of things we have. And because of stacking is the most important part, and nowadays it's very demandable. Like when I have given some interviews, and regarding the interviews, the interviewer asked the questions would be regarding stacking and VSS and all the things. So that was very interesting. And because of I just remember the concept, so I have easily cleared the round and all the things. So you can do one thing, you can just take a snap this like feature stacking versus VSS. Okay, like in the stacking we have the uses properly cabling and all the things. Okay, but into the VSS, what kind of models which is we have to use into the VSS and all, what kind of model we have into the stacking and all. Okay, then we will move to the next part. Then I think you will have some kind of idea about that, like how it works and what kind of things which is we have in this. Okay, so like we have cabling, we have distance supported, and we have chassis member, and we have platform switches, and then we have control plan, switch size, add remove members. Then we have control and management traffic as well. So these kind of things which is we can use it, and we can forward it with the using VSS. Okay, just take a snap and just let me know after that. Done, guys? Everyone? Say yes, no, something.
Ajay,
Yes,
say
yes.
yes, ma'am.
Okay, fine. Yeah, any doubt, anything else that you want?
So Ajay, here I need to clarify. You're telling us aggregate with up to 16 links, aggregate up to 8 links. So aggregate means here you're trying to tell us a bundle.
See, if I'm talk about the 8 links and 16 links, basically, let me draw the scenario, then you can understand. Suppose that this is our switch 1, and here we have that is switch 2. Okay, so we have 16 links in that. Suppose that 1, 2, let me make it. Okay, and 8 links would be in the standby mode. Now, see, suppose that the every port having the some cost like 12.5. Every port having the same cost. Suppose that, and this one is also having 10.5, 12.5. So suppose that if any link goes down, okay, suppose that this link goes down or this link goes down, so what will happen? This cost is going to add with this link, because of this is the standby link which is we have, because of in LACP the 8 link would be in the active form, this 8 link would be in the active, and this 8 links would be in the standby. Okay, so what will happen, like whenever the any active link goes down, so then we have the some backup of the particular port. So what will happen? The cost will add over here directly. The cost will add over here. Okay. So because of previously it was there was no use of it, so there was no cost. Okay. So whenever it will turn on, then automatically the cost will be added over here. That is 12.5, and this will comes into the blocking state. Okay, so this is work like this, the LACP. Okay, did you get the point now?
Oh, okay.
Okay, so I think everything is clear regarding the theoretical session. So
Jay,
yeah,
I have a doubt, Jay. Can
yeah.
you please tell about how to update iOS for this VSS? Stacking, I know, without any problems I done, but in VSS, facing many issues while updating the iOS.
See, for the VSS, if I'm talk about, first of all, we have to bundle the link, okay, by using the Ether channel, and we use the VSS on the Ether channel, right? Suppose that this is our Ether channel port channel one I have created, and this port channel having the VSS, okay. Now this VSS having the some virtual link, and this link would be named would be any kind of name you can give it. Now if you wanted to upgrade any kind of operating system or something like that, so you can directly go on the virtual link and directly you can go in the Roman mode, okay. So there will be the some different configuration to go in the Roman mode. So like there will be some steps which is we have to follow. uh, Let me show you how to go Roman mode. So basically, the Roman mode, you will give this kind of whenever you will take the reboot, okay, then you have to press the Control plus Break button. Like if you will see in your keyboard, so there will be the break down button over here. Okay, so break button you have to use, and then you will get entered into the Roman mode. Okay, so we have to follow the some process as well for this Roman mode, like, and the Roman mode would be like this. Okay, like whenever you will take the access, it would be looks like this. Okay, so that would be also does matter. Like you can directly go in the Roman mode by taking the reboot of the device. Is it fine? Any doubt, guys? Any of you have any doubt? No.
No.
Thank you. So I'm going to stop the recording and let's perform the practical. Okay.